5 is an adding fraction problem. The denominators need to be the same. So, if you notice, they're opposites of each other. So if you want to change this 9 minus 3x to 3x minus 9, so they match, all you have to do is multiply the denominator by a little -1. And then the 9 will become a negative, and the 3x will become a positive. But of course, if you multiply the bottom by a -1, you have to multiply the top of the fraction by a -1. Because what I'm really doing is multiplying by 1. A fraction is allowed to be multiplied by 1. So here's my first fraction. Stays the same. Now on the top here I have 6 times -1, which is -6. And on the bottom I have the -9 and the positive 3x. Now I can add these two fractions together. I leave the same denominator. Add the numerators, 2x minus 6. Now, chances are, if you're adding, subtracting, multiplying, or dividing fractions, you're probably going to have to reduce it to lowest terms. And in fact, this can be reduced. On the numerator, I can factor out a 2, GCF, leaving me x minus 3. And on the bottom, 3x minus 9, I can take out a 3, and that leaves me x minus 3. And the x minus 3's cancel, and my final answer is 2/3. Now listen to me out in YouTube land. Try this again on your own. 7 on the pink sheet. Number 7 has to do with perfect cubes. So it's just like perfect squares. You're going to look for perfect cubes that are in 81, x7, and y5, y to the 5th. So let me write some of my cubes down. 2 times 2 times 2 is 8. 8 is my first perfect cube. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, and so on. Perfect exponents, perfect cube exponents would be exponents that are multiples of 3, like x cubed, x to the 6th, x to the 9th power. Any exponent that's a multiple of 3 is a perfect cube. So, I'm going to break up my 81. 81 divided by 8. No. 81 divided by 27. Yes. 27 times 3. 27 is a perfect cube. Now, x7, x to the 7th power. I'm going to break it down to the biggest perfect cube exponent, which is 6. X to the 6th times x to the 1. X to the 6th is perfect. And now my y to the 5th. The only one I guess it'll break down to is y to the 3rd. That's perfect. Times y to the 2nd makes y to the 5th. Okay, so now all my little bubbles are going to pop. The cube root of 27 is 3. The cube root of x to the 6th is x squared. It's sort of like you take the exponent and divide it by 3. X squared times x squared times x squared is x to the 6th because you add the exponents. And the cube root of y cubed is y. And then stuck inside my cube root is 3x and y squared. Try that one again on your own. Pink review packet number 8. Describe this transformation and maybe even do a sketch. So let's go over that. Remember the library of functions? The ones that you had to remember were x squared function is the parabola. Remember that? And your square root function looked like an airplane taking off. And remember your x cubed function, that was the squiggle. Remember him? And then there was the absolute value, which is this one. And that was the big. So what we're going to do now is we're going to take one of these basic, this one is the absolute value, and we're going to move it around, shift it, flip it, do a few things with it. And we want to describe in words what happened to the absolute value function. So the first thing that happened is the function was negated, which means it's upside down. It was reflected in the x. Then inside, opposite, slide. So it went left, 3, and outside, go with the flow, high, low, it went up, 2. So if I wanted to do a little sketch, here's my basic absolute value. I turn it upside down. I go left 3, up 2, and that's what the sketch would look like. Okay, go ahead.
Will we have to sketch it on the...
I don't know, you might have to. So I want you to memorize them. Upside down, inside, opposite slide, outside, go with the flow, high, low. Normal problem. This is contaminated. Why is it contaminated? Because the x is negated. That negated x was distributed through and made this look negative, but it's really a positive 5. So if I was to just take the little negative away from the x for a second, you would see that it was really negative x minus 5. It was really a plus 5 shift. So a contaminated shift will change this to, instead of it looks like it would be a positive 5, I mean it looks like you go right 5, but in actuality you're really going to go left 5. So it kind of makes inside go with the flow. You know what I'm saying? It contaminates inside, so instead of going opposite slide, it's going to go with the flow. Are you videoing me? Upside down. Inside, opposite slide, left 2. Outside, go with the flow, high, low, so it's down 3. So it's a regular V, upside down, left 2, down 3. Contaminated, negated x, means it's going to actually go with the flow. It's going to go left 5. Why is it going left 5? Because that's really a positive 5. That was negated by that dopey negated x. So I'm going to, since it's a negated x, that means a reflection in the y-axis. Don't forget that that is a reflection of the y-axis. But now I'm going to go left 5, and I'm going to still go up 4. That wasn't affected. So now a V reflected in the y-axis looks exactly the same. So now I'm just going to go left 5, up 4, and there's my V. Factor completely. Now, I'll tell you right now, this is a beautiful Superman problem. But what's scary about it, factoring completely, is this x to the k. You all see that there's an x to the k. That's a common factor. I'm going to factor x to the k out. Now, when you have a 6x to the k plus 2 and factor out an x to the k, watch what happens. You're left with a 6x squared. How is that? 6 times 1 is 6. X to the k times x to the 2 is x to the, add the exponents, k plus 2. Right? You add the exponents when you multiply. So do you all see how that works? X to the k times 6x squared is 6x k plus 2. Now I'm going to factor in x to the k out of this term. So I'm left with 11. X to the k comes out, and I'm left with x to the first. And then I factor in x to the k out of this term, and I'm just left with a negative 10. So this is just the GCF. Now, you know when a problem says factor completely, there's got to be more than one step. So the GCF comes out, and now Superman. We're not afraid of Superman. Superman goes like this. You multiply the first coefficient, the A coefficient, with the C coefficient, and that'll give me a negative 60. I'm looking for two numbers that multiply to negative 60 and add to a negative 11. 2? 30? No. How about 4? 4 times 15. 4 times 15 is 60. And the difference is an 11. But I got to make sure that I have the negative 11. So I'm going to make the 15 negative, 4 as a positive. So then what do? You drop down the first term of the trinomial, drop down the 6x squared. You drop down the negative 10, the last term. And you split the negative 11x into 4x and negative 15x. 4x and negative 15. Negative 15x. And then you kind of like broke it down into 4 terms, and you're going to regroup. And you're going to GCF the first 2 terms. I'm going to take out a 2 and an x. And that's going to leave me with, when I divide out a 2x, 3x plus 2. Then I'm going to look at the last 2 terms, and I'm going to factor out a negative 5. And guess what that's going to leave me with? 3x. Negative 10 divided by negative 5 is positive 2. Woohoo! So now I see another common factor between these 2 terms, 3x plus 2. So I take the 3x plus 2 out, factor it out, leaving me a 2x minus 5. And don't forget the GCF. And this is called factored completely. Sometimes my students love to, at this point, start tea-timing. Why am I not tea-timing and solving? Because there's no equation. This is not an equation. It's just an expression that needed to be factored. So I stop at the factors. You're given a division problem. You're going to take this long polynomial and divide it by this binomial. We're going to use synthetic division. So what you're going to do is you're going to set it up like this. Outside, you're going to put the root of this factor. So what does that mean? Take this factor and in your mind, t-time it. Set it equal to 0 and solve. What would the root be? 2. You all agree the root is 2? That's going to go on the outside. Now on the inside of the division, you're going to put the coefficients of the polynomial from highest exponent to lowest exponent. So let me go slowly. The coefficient in front of the 4th degree term is a 3. 4th degree. Then you're at the 3rd power. The coefficient is negative 6. Then I'm looking for the 2 power. The 2 power is missing. So what do I put?
0.
0. Good. Then I have the 1 power. I have a coefficient of negative 5. And then I have the 0 power, which is the constant 10. So 4th power of x, 3rd power, 2nd power, 1 power, no power. And now I'm ready to do my synthetic division. I drop. I multiply. I combine, drop it down. Negative 6 and positive 6 is 0. I multiply. 2 times 0 is 0. Put the answer there and drop by combining. 0 and 0 is just 0. I multiply. 2 times 0 is 0. I drop. Combine negative 5 and 0. I'm left with negative 5. And then I multiply again, and I get negative 10. And my constant cancels out. When your constant cancels out, you know it divided evenly with no remainder. So now you just have to know how to write your answer. If you started with a 4th degree polynomial and divided it by a 1 degree, you'll be left with a 3rd degree. So this is really the coefficient of x cubed. This is the coefficient of x squared. This is the coefficient of x1. And this is the constant. So my quotient after I divided is is 3x cubed minus 5. The squared term and the x term you don't have to write. And we can do more of those. Actually, on pink sheet number 30, step by step, I'm going to go through this. There is a farmer, and he's going to build a rectangle. I want you to draw the rectangle. He's using 3,000 feet of fence to build this enclosure. And we want to find the maximum area. So the first thing I think you should do is draw the picture. Then label it with dimensions, but you don't know the dimensions. So put W for the widths and L for the lengths. Now, the next thing you should do, since you were given the 3,000 feet of fence, is make a formula, make an equation for the perimeter. So the perimeter is 2 W's plus 2 L's equals 3,000. That's true, right? Because that's what he's building. The 2 W's and the 2 L's are going to equal 3,000. Now I need to find the area, because that's what I'm trying to find. I'm trying to maximize the area. I need an area problem. To find the area, if I just do length times width, I'm going to have 2 variables in my area formula. So I need to solve for one of the variables in terms of the other variable. So I don't know, what do I want to solve for? I'm going to solve for L. So to solve this equation for L, I'm going to subtract the 2W away. That leaves me 3,000 minus 2W, divide by 2, and I have now figured out 3,000 divided by 2 is 1,500, minus 2W divided by 2 is negative 1W. I have just figured out that length is equal to 1,500 minus W. So I'm writing the length in terms of the width. I'm writing the length in terms of the width. Why? Because I'm going to find the area. And when I find the area, I just want one variable so I can maximize. So I'm going to find the area now by multiplying 1,500 minus W, which is the length, times the width. And that's going to give me the formula for area. Area is length, and I use the perimeter problem to get that, times the width. So now my area is expressed as 1,500 W minus W squared. And that is my area expression. Now I have to maximize it. I got to find the max area. Now, whenever you want to find the maximum of something, you're always going to find the axis of symmetry. So W, instead of X, I'm putting W because that's the variable, minus B over 2A. So I take the negative B. Now be careful here because the negative 1 is the A number. That's in front of the W squared. And the 1,500 is the B number. They're written backwards. So my B number is negative 1,500 times 2 times A. My A number in this quadratic is negative 1, which gives me 1,500 over 2, which is 750. So the axis of symmetry is at W equals 750. That means that when the width is set as 750, I'm going to get the most area, the maximum area. So it depends what the question wants to know. Do they want to know what the width should be to get the maximum area? Or do they want to actually know the maximum area? If you want to find the maximum area, well then all you have to do is plug this in for W. So let me write my rectangle again. The W is going to be 750. The length is 1,500 minus 750, which is 750. And in actuality, it's a square. And if I build a square, I'll maximize my area. It'll give me the most area, which is 750 times 750. Which, whatever that is, 750 times 750. All right, another farmer question. So Farmer Jack is going to build a rectangular pen bordered by a river. So he doesn't need to put the fence along the river. He just needs to build the fence on 2 widths and 1 length. He needs to use 3,000 feet of fence. We want to know what's the biggest enclosure he can make, the maximum area that he can make. What do the dimensions have to be to maximize my area? So I need an area formula. But before I can find the area formula, I need to use the perimeter formula to solve for one of the variables in terms of the other variable. So once you draw a picture and you have the perimeter, write out the perimeter formula. So here it's 2W, this is the perimeter formula, plus a length is going to equal 3,000. That should be easy, right? Just write the perimeter formula. Now, solve for one of the letters in terms of the other letter. Well, you all see that to solve for L would be very easy. All you have to do is subtract the 2W away. So I'm going to do that. Woohoo! Bye-bye. And I have just solved for L. Now, take that, whatever L is equal to, and replace it, substitute it into your picture. So instead of the letter L, I am replacing it with 3,000 minus 2W. Beautiful. So now I have the length and the width in terms of W's. Now I can make an area expression. To find the area, I'm going to do length times width. It's always going to be length times width with rectangles. And I have W times 3,000 minus 2W. And I'm going to distribute so it looks like a beautiful quadratic equation. I got 3,000W minus 2W squared. Be careful at this point. If you don't like seeing a parabola, like in a quadratic equation, backwards, you can rewrite it. You could put the negative 2W squared first, because that's your A term, and your 3,000W as your B term. And then finish off your problem. Your problem is maximize. Maximize the area. To maximize anything, you're going to find the axis of symmetry. W equals minus B over 2A. Negative B, which is negative 3,000, over 2 times A, which is negative 2, gives me negative 3,000 over negative 4, which is equal to 750 W. So if the width is 750, so let me draw the picture again. Here's my rectangle, here's my river. If my widths are 750 and my length is 3,000 minus 2 times 750, which is 3,000 minus 1,500, which is 1,500, that will give me the max area. And if they ask me, well, what is the max area? I just multiply the width, 750, times the length.